right, so in today's lesson, we're going to be learning about infinite limits, and we've already actually really learned about these. If we look at the definition of an infinite limit, it's just a limit where f of x increases or decreases without bound as x approaches a certain value. If you remember, we've learned that phraseology before. Whenever something increases or decreases without bound, when you're talking about limits, that means that your limit is undefined. So infinite limits are technically a categorized limit that does not exist. So this limit actually doesn't exist, but to help us understand it a little bit more, we do have two types of infinite limits, and we'll talk about that today. And in tomorrow's lesson, we'll learn more about why even bother with infinite limits, because they do help us solve some problems on down the road. So it's better to have infinite limits than to just say, oh, it does not exist, and be done with it. So let me kind of show you what I'm talking about in a visual example. And you guys can just watch, you don't have to write this down. But say we have an asymptote going through x equals 1 right here. And then our function looks something like this. So before, if we talked about the limit as x approaches 1, we would just say, oh, the limit does not exist. We would say the limit of f of x as x approaches 1 does not exist. That's all we would say. But now that we've learned about limits from the left and right sides, we can be a little bit more specific. So instead, we can say that the limit of f of x as x approaches 1 from the left, little negative sign means left, well, if we come in, we can see that it's decreasing without bounds. So now we're going to call that negative infinity. So we would say that this limit equals negative infinity. Now, keep in mind, nothing actually equals infinity. It's just a concept. It's not a number. But for the sake of some mathematical things that we're going to do on later down the road, tomorrow's lesson, we're going to put an equal sign there. So we're going to say the limit equals negative infinity, although technically the limit does not exist. Mathematicians understand that infinity is not actually a number, so it's implied that when your limit equals infinity, that actually means it does not exist. So that's from the left side. Now, if we look at from the right side, we can also determine an infinite limit. We can say the limit of f of x as x approaches 1 from the right, little plus sign there, that would equal positive infinity, because you can see it's increasing without bound. So we'll flesh that out with a couple examples in our notes, but I just wanted to show you exactly what I'm talking about when we define an infinite limit. And then we're also going to talk about vertical asymptotes, which you guys learned about in Algebra 2. And we also learned how to find vertical asymptotes, but you may not remember exactly. So we're going to go over that again. But a vertical asymptote is just a line that the graph comes arbitrarily close to but never touches. So this is our graph, these lines here, and this is not actually part of our graph. That is the vertical asymptote. So in your words worth knowing, if you want to draw a little diagram or something like that, then you can. If you remember what it is, good for you. You don't need that visual aid. Now let's go ahead and start with the lesson.